Okay. First one starts with a proof. As I mentioned with a lot of the proofs, you don't have to fill in every single blank. However, with this specific one, it does require you to fill in all the blanks. What's nice is all the statements and reasons are down here. It's just about like putting it in the right spot. So, looking at what it says, a figure is shown where DE is parallel to BC. Okay. It wants us to prove that the angles of the triangle add to 180 degrees. Where we're headed with this, they put the given in here. Since those lines are parallel, these are transversals, and alternate interior angles are congruent. So this angle is equal to this one, and that's your first statement right here. So angle, and the answer bank is right here. I'm going to go with this one. Angle DAB is equal to angle ABC. And so, yes, no, you need to write it out for right now. But on the computer, yes, you'll drag and drop it. Be careful though, on the computer, you can't like draw on the screen. I wish they had like some kind of marker or something you could draw on the screen, but they don't. So you might have to like sketch this out on your piece of paper so you can see all the different parts. Number 3, now we're going to say that this angle is congruent to this one, because alternate interior angles are congruent. So EAC is equal to ACB, and that's this right here. We would drag and drop it here, but we're going to write it out. EAC is equal to ACB. Oh, I forgot to drag and drop the reason. So when I said this alternate interior angles are congruent, here's the reason right here. You would drag and drop this here. Alternate interior angles are congruent. I'm just going to leave it alternate interior angles. But this says if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. And that would be the same reason for the next one. So drag and drop the other one here. Okay, now it gives us the statement angle DAE. Looking at this, that is a straight line, is 180 degrees. The reason why is because of, and it's between these two, so it would have to be supplementary angles. So this gets dragged right there. Okay, and the next one. We have 2 statements left, so we just have to choose between those 2 and figure out which order. The reason says angle addition. Angle addition would be like this angle plus this angle plus this angle equals the entire thing. So in terms of my statements, I'm going for this one. This is the one we're going to put in 5. Angle DAB plus angle CAB plus angle EAC equals the entire thing DAE. That's angle addition. And that leaves these 2 are our answers we have left over. Angle DAB plus angle CAB plus angle EAC equals 180 degrees. And the reason is, so this would go here, the reason here is substitution. Next. Okay, moving down to the next one. It says that points A, B, and C are collinear. That word right there means that they fall in a straight line. So, fall in a straight line. Collinear doesn't mean that it has a line drawn through it, so keep that in mind as well. It says that AB to AC is 2 to 5 or 2 to 5. Point A is located at -3,6. Point B is NQ, so we're going to solve for those coordinates, and point C is located at -3, -4. What are the values for NQ? You might be thinking, oh, we need graph paper. You do need graph paper, but because we don't have any in front of us, we're just going to sketch a coordinate plane out here. Your scratch paper will have graph paper on it, so you'll be able to sketch stuff out. Now here, I'm going to sketch the 3, 4, 5, 6. It needs to go up at least 6, by the way. Let me go out 5 this way and go down 5. Okay, starting by graphing point A. Point A is at negative 3, 6. So graphing that right here. A is at negative 3, 6. B, we don't know, and point C is located at negative 3, negative 4. And then I'm going to connect those dots to make the line segment. Okay, so it says AB to the entire segment is 2 fifths, or 2 parts of 5. So we're going to split this up into 5 equal parts. This is at 6 and this is at negative 4. So this entire segment is 10 units. So if we break it up every 2 units, it'll break it up into 5 equal parts. There's a 5 equals 1, 2, 3, 4, 5 equal parts. AB to AC is 2 to 5, so B would fall right here. And the coordinates for that are at negative 3, 2. So N is the X coordinate, so that would be negative 3, and Q is the Y, so that would be 2. Not too bad.
How long have we been on our EOC?
What's that?
How long do we have on our EOC?
I think it's 90 minutes-ish.
2 sessions, right? Yeah, 2 sessions.
Okay. Then over here, this one's pretty easy too. If you know what they're looking for, it's pretty easy. It says you have quadrilateral MATH. Huh, they spelled math. Cool. It's dilated by a scale factor of 2.5, centered at 1, 1. So the center of dilation is right here. When you dilate it by a scale factor of 2.5, that means all the points get 2.5 times away, and the segments get 2.5 times as long. So like M prime would be out here-ish. So I'm just like doubling that segment and adding like 0.5, so it would be like right here, M prime. And T prime, doubling this segment and then adding 0.5. It doesn't have to be exact because we're just going to be focusing on the concept when we answer the questions. H would be 2.5 times away. So maybe right here, H prime. And then connect it. There. Okay, there's our dilated shape. Select all the statements that are true about the dilation. Is MA congruent to MA prime? No, MA prime is a lot longer, so nope. AT will overlap AT. Yes, it does overlap. That is correct. MA prime will overlap MA. Yes, it does overlap. The slope of HT is the same as HT prime. Yes, those slopes are the same. And then the last one, the area of MATH is equal to 2.5 times the area of MATH, the original. That is not correct. The side lengths would be 2.5 times as long, but the area would be even greater than that. So, no. And remember with select all, 2 to 3 correct answers is what you're looking for. Okay, and the next one. Another dilation question. Says triangle R, it shows RTV, the original, then RTV prime is formed using the transformation of 0.2x times 0.2y centered at 0, 0. So the dilated shape would be 1/5 the size. Now we're going to answer the question. Select the 3 equations, so they're telling you exactly how many are correct, that show the correct relationship between the 2 triangles based on the transformation. Okay, the first one says that segment RV, I'm going to use a different color, RV equals 5 times this. Yes, if you multiplied this by 5, you would get the length of that. That is correct. Now they're setting up a proportion. RV prime is the small one, so I'm going to label that with an S, and RV regular is the big one. And then where'd they get this square root of 26 from? I'll show you. Square root of 26 is the length of that segment. If you were to find this length, 1 squared plus 5 squared equals c squared, you would get square root of both sides, square root of 26. So the square root of 26 is that length. Okay, so what is it saying? It's saying small to big, and then 0.2 times square root of 6 would be the small one, and this would be the big one. This doesn't work because you have small over big and then big over small, so this is not correct. The next one, 0.2 times square root of 10 and times the big one equals the small one. That is actually correct. Next one, the small one times 0.2 would not equal the big one. That is not correct. 0.2 times TV prime, does that equal TV? Nope. And then here we have big over small and big over small. It works. This one's correct as well. And the bottom of the page now. Okay, this example is kind of weird if you haven't seen it before. We have seen this diagram before. Remember, this altitude creates 3 similar triangles. So there's a triangle here, there's a triangle similar to it right here, and then the larger triangle is also similar to those 2 triangles. Erasing this now. Okay, looking at the proof, we only have to fill in these 2 spots. There's actually a drop down here which will have answer choices, so you're not coming up with this like from out of thin air. You'll just choose it from the drop down. For 3, it says definition of similarity. Proportionality would prove similarity. So the answer for 3 is actually A over D equals C over A, and B over E equals C over B. And there are a bunch of answer choices that you'll be able to choose from. This is correct, and you know it's correct because of the proportionality. So here they have A to D, so that's long to the medium side is equal to C over A, long to the medium side of the other triangle. And the next one, B over E, long to the short side is equal to long to the short of the larger one, and it works. Number 5, when you look at the answer choice, you'll be like, where did they get that from? I'm going to do number 4 just so 5 makes sense. So to get to step 4, you actually do cross multiplication. So you get A squared equals CD, and B squared equals CE. That is for step 4, which isn't part of the problem, but you need it to get to the next step. Then for 5, they say A squared plus B squared equals CD plus CE. And addition property of equality. So since these are equal, you could add it to both sides, and your equation would still be equal. Next. Actually, I'm going to stop my recording here because I don't want it to cut off.